This lecture is in continuation with flexible pavement design lecture 1. So let's see now more information about load, how you will standardize the load. You have already seen the different types of vehicles as per their axles running on the roads. So the question is that how to calculate the damage incurred from the various class of vehicles. You have already seen cars, trucks having single axle, trucks having tandem axle, trucks having tridem axles. So these all axle configuration will make different amount of damage, different type of damage to the pavement surface or pavement structure. Now, how to estimate the damage caused by this individual class of vehicle? So if you want to estimate the damage from these individual class of vehicle, it will make your problem more complex. Rather than if you standardize these all class of vehicle into some standard class of vehicle and then you measure the damage caused by that standard class of vehicle, that will ease your problem. Let's try to understand this thing in more detail. So mostly in roads you have seen the trucks which are having single axle, which some trucks which are having tandem axles, some trucks which are having tridem axle. Here these axles are referring to the rear axles of the truck, not the steering axles. So now if you want to measure the damage caused by the individual truck class, it will make the problem complex. So rather than making estimate of damage caused by the individual class of vehicle, the strategy to convert all the vehicles of different axle configurations into a standard axle configuration is adopted. So in India or in many countries, a single axle dual wheel configuration having 18 kips of load is taken as a standard axle load. So here this standard axle load is having two wheels on each side, and on each side is having a load of 9 kips, which comes out to be total 18 kips of load, which is approximately equal to 80 kilonewtons load in SI units. So in SI units, you may have 40 kilonewtons load on each side and 20 kilonewton load on each wheel for a standard axle load. Now we have seen that we have a different classes of vehicles. Your vehicle may have a single axle, may have a dual axle, single axle dual wheel, it might have tandem axles, it might have tridem axles. So all these axle configuration, we need to convert them into our standard axle load, that is single axle dual wheel. So let's see how to convert all configuration or load configuration into a standard axle load, that means into a load of single axle dual wheel. Suppose I have a vehicle, Mazda Miata. This is essentially a car which is having a curve weight of 2300 pounds, and it can make around 12 millions number of passes on the road before its total failure. So the main information what's given to me that the road can support only 12 million number of passes for this Mazda Miata whose curve weight is 2300 pounds. So the damage will be incurred in each passes, and after 12 million number of passes my road will be fully damaged. So damage incurred in each pass can be estimated by 1 upon the number of passes. So let's assume the damage caused by Mazda DM equals to 1 upon the number of allowable passes on the road of this vehicle Mazda Miata, that is, let's take as NM. Similarly, I have one more class of vehicle, that is Ford Excursion, whose curve weight is higher than your Mazda, and it is 6,300 pound. So its weight is high, that means it's going to support less number of passes by the pavement. Point 0.2 million number of passes can be safely supported by the pavement before its failure. So the damage caused by this Ford can be estimated by 1 upon the number of allowable passes, which is 0.2 millions. Now let's assume I have some standard question mark manufactured vehicle whose curve weight is 4,300 pound and pavement can support 1 millionth number of passes for this standard vehicle before failure. So the damage caused by each passes can be estimated by 1 upon the number of passes allowable for this standard vehicle. So let's name the damage for a standard vehicle on each passes is ds, that will be given by 1 upon ns. Now let's estimate the load equivalency for your Mazda. So the load equivalency factor Fm, let's assume, will be equals to the damage caused by the Mazda on each pass upon the damage caused by standard vehicle in each class. That can be given as 1 upon Nm and divided by 1 upon Ns. So you will get the Ns upon Nm. That means the number of passes by standard vehicle upon the number of passes which can be supported by the pavement by your Mazda. If you input the value, you will get the factor estimated as 0.083. Let's try to understand what this factor Fm means. This factor Fm signifies that one pass of Mazda is equals to or equivalent to 0.083 times passes of a standard vehicle. That means one pass of Mazda is equal to 0.083 times pass of your standard vehicle. Let's try to understand this by one more example. Similarly, can you estimate the load equivalency factor for the Ford? Let's estimate that. So for Ford, if you remember, it can be estimated by damage or by each pass caused due to Ford upon the damage by standard vehicle in each pass, that will be 1 upon NF upon 1 upon NS, that will be NS upon NF. So your equivalency factor for Ford will be given as 1 million upon 0.2, that will be 5. What it means? It means that one pass of the Ford is equivalent to the 5 number of passes of a standard vehicle. So if you want to convert the 0.2 millionth number of passes to a standard vehicle's number of passes, you can multiply this factor with the number of passes of Ford, and this will convert the Ford's number of passes into an equivalent number of passes by your standard vehicle. We have already seen that the damage can be represented by fatigue, rutting, or various performance parameters. Here in case of flexible pavement, most of the time we will try to represent the performance of the pavement in terms of either fatigue or rutting. And in case of rigid pavement, it would be because of fatigue, cracking, or due to erosion. So here the damage what we have defined, based on that definition of damage, we can modify these equations. In case of fatigue, if this is the fatigue equation of for asphalt pavement, here NF is the fatigue life, the number of passes, and K1 epsilon t to the power minus K2, where epsilon t is asphalt tensile strain. Then using the same expression, you may have load equivalency equation as tensile strain incurred in ith vehicle upon the tensile strain incurred due to standard vehicle to the power K2. This factor will give you load equivalency factor, and normally is being seen that this K2 or this power comes in between 3 and 6. Similarly, you may have criteria for rutting. Here this strain will be subgrade compressive strain. We have already discussed how to measure fatigue and rutting, why it is incurred. So here the rutting is because of the failure in subgrade. So the strain which will be taken as a subgrade compressive strain, we can submit this to our equation, and here we can get the compressive strain in your X class of vehicle upon the compressive strain due to the standard class of vehicle to the power K4, where K4 value can be in between 3.5 to 4.5. In case of rigid pavement, this failure due to cracking can be given by this expression. Again, let's input this expression into your factor calculation expression. This will give you whatever stress you have in the ith vehicle upon the stress in the standard vehicle to the power 4. So here, to summarize these all things, the load equivalency factor can be given by these all equations, and in nutshell it can be given by the measured axle load of the vehicle for which you are determining the load equivalency factor upon the 18th kip standard axle load to the power 4. This is known as fourth power law model. Let's try to understand what it means. So suppose if you have a vehicle whose curve weight is A, and you have a standard vehicle whose curve weight is, let's suppose, A18. So the load equivalency factor for 8th class of vehicle can be given by the load A upon load A18 to the power 4. This will be their load equivalency factor, or the factor which you need to multiply with the number of passes of AS vehicle to convert it into a standard vehicle's number of passes. Let's try to solve an example using this fourth power law model. Let the number of load repetition expected by 80 kilonewton standard axle load is 1000, 160 kilonewton is 100, and 40 kilonewton is 10,000. Find the equivalent axle load. So in this case, the standard axle load is 80 kilonewton. So we want to convert all these loads of 80 kilonewton, 160 kilonewton, and 40 kilonewton into a standard axle of 80 kilonewton. So how to do that? This load divided by 80 kilonewton to the power 4 for each load category of vehicle, and then take the summation of that. Let's see this. So I have three class of vehicle. First is weight is 40 kilonewton and its number of passes is 10,000. So for this 40 upon 80 to the power 4, that will give you a factor of 0.0625. This factor multiplied by this number of passes will give you the number of passes equivalent to the passes of standard axle. Similarly, you can take 80 upon 80, that will give you 1 because it's a standard axle as well. So it will give the value of same what number of repetition it has. Then the load of 160 divided by 80 to the power 4, that gives 16. Number of passes given is 100 multiplied by 16, that gives a 1600. The summation of these all 625, 1000 and 1600 will give you the total number of repetitions of a standard axle on the pavement. and this number will be regardless of any axle configuration. This is the number of passes which will be made by a standard vehicle whose weight is 80 kilonewton. For different class of vehicle to convert into a equivalent standard axle load, these expressions are specified in IRC 37, which is code to do the flexible pavement design. So if you have single axle with single wheel on either side, you have to take the axle load in kilonewton divided by the 65 to the power 4. Similarly, for all types of vehicle, suppose if you have a tridem axle, you want to convert them into a standard axle, you have to take the axle load of that vehicle divided by 224 to the power 4. That will give you the equivalent axle load factor for this class of vehicle. So now you have equivalent axle load factor, which when multiplied to the respective class of vehicle, the number of passes of that class of vehicle, it will convert it to the number of passes of standard axle load. So if you have three different classes of vehicle, you will have the value of, you have 3 EALF value to convert these vehicles into a equivalent standard axles. Let's try to understand this conversion of vehicles into a standard axle load by an example. So this is an example of traffic load survey. So here you can see for single axle there are different load groups. So this is the load group when the load is between 3000 to 6999 pounds, and similarly you have different load groups, and in those load groups there are number of axles which are passing to the pavement. These are the data of single axles loads which are passing on the pavement, and this is collected for 1000 number of vehicles. So in 1000 number of vehicles we have different load spectrum. So vehicle may range from this load to, let's suppose, this load, and these are the numbers of the corresponding load. So like a load between 3000 to 6999 pounds have a axle counts of 557 when you have a data for 1000 trucks. For this you can estimate the load equivalency factor because you have load and you have the standard load, and you can calculate the equivalent standard axle load by multiplying this factor with the number of count. Similarly, you can do for all class of load and you can find the equivalent single axle loads, and you may have a summation of those loads. So in class of single axles there are different load groups. In load groups you have the counts of number of passes for the respective load groups, and when you have converted to the standard axle you got that 1000 number of vehicles are equivalent to 229.2 number of passes of standard axle load. Similarly, for the same road, for tandem axle, the data of 1000 truck is recorded. Here also you have different class, different configuration or different spectrum of load, and for all loads category you are provided with the or recorded with the number of repetition of corresponding load group. For that you can estimate the value of LEF, and by multiplying this LEF with the axle count you will get the equivalent single axle load, and here for 1000 number of repetition you get the 169 number of repetition made by the standard axle load. Now if you have single axle and tandem axle and different classes of load, you have to make this calculation or this mathematical computation for whole groups for the whole design period. There is one more way to do that. We have a data for single axle, we have a data for tandem axle. For both we have taken the count of 1000 truck, and we have calculated the equivalent single axle loads. So what we can do, we can take the average of these. So we have equivalent single axles corresponding to single axle and equivalent single axle load corresponding to tandem axle. Do the summation divided by the total number of vehicle, that is 1000. This gives a factor of 0.40. What this factor means? This factor means that if you have provided with the number of repetition, or more simply, if you are provided with the total number of traffic moving on the pavement, that traffic multiplied by this factor will directly give you the traffic in terms of standard axle load. Here you don't require any vehicle configuration or any load configuration data. Just whatever the number or the total traffic moving on the pavement multiplied by this factor will give you the traffic in terms of standard axle load. This factor here is known as truck load factor, or in terms of IRC, this factor is known as vehicle damage factor. We'll use this vehicle damage factor in our various design problem when we'll see how to solve or how to design a pavement using IRC 37 code. Now let's see the design criteria for designing a flexible pavement using IRC 37. So we have already seen that the standard load which is taken for design is the single axle dual wheel configuration. So this is the tire which are representing the single axle dual wheel. So one side two wheels are represented by these two tires. So the two main failure mechanism we have already seen is fatigue and rutting, and fatigue occurs at the bottom of asphalt layer. So here in this pavement, this is the layer corresponding made up of bituminous material, this is made up of unbound material, and this is your subgrade. So to analyze fatigue, we have to take the tensile strain at the bottom of this bituminous layer. So here in the junction of your bituminous layer and your granular layer, here at this point, that means at the middle of both the tires and one point at the center of one tire, we need to determine the tensile strain. Now here this point is in the junction or in the interface of this bituminous and this granular material, but this point is inside the bituminous, not in the granular. So this point will be considered just in interface inside this bituminous layer. Similarly, we have to make our measurement for vertical compressive strain over the subgrade for rutting. In this case also, we have to get the strain at these 2 points, and these points will be assumed to situated on an interface but towards the subgrade side, not on the granular material side. So this will be on the top of subgrade in subgrade side, and at this point we have to determine the vertical strain. So at 2 point the tensile strain, and at 2 point the vertical strain. These points will be at the bottom of bituminous layer, and these points will be at the top of your subgrade. So these two strains we have to determine. Now in this course, till now we haven't seen that how to determine stress and strain when some loads are given over the pavement. In case of your soil mechanics, you have seen the various theories like Bosnisk theory to determine, or some multi-layer theory to determine the stress strain if some load is given. Here in this course, this is beyond of our scope, and we are not studying any methodology to determine this stress and strain. mathematically, but we will try to determine this stress and strain by using a software. That software is developed by IRC 37 program, which is being conducted by IIT Kharagpur. So we'll try to refer that software, that is a small Java based software. In that software, if you input these value correctly, you will able to calculate different strains. Let's have a look on the IRC software. The software is popularly known as IIT Pave and is being developed by Transportation Engineering Division, Civil Engineering, IIT Kharagpur. Here, this is a Java-based easy program. We'll have a different video to explain you how this program will work. This is the main page of the program, and in this main page, you can select design. There will be a different data input form will be opened. In the data input form, you can input all the information like what will be the number of layers in your pavement. So let's here in this example, it is being taken as a 3-layer pavement system. So here you can input the elastic modulus corresponding to each layers, the Poisson's ratio, and the thickness of each layer. So if it is a 3-layer pavement system, so last layer is going to be a soil or subgrade. 2 layers will be of maybe top layer bituminous layer, and maybe middle layer made up of some granular and other materials. Then you need to provide the information about wheel load. So it's an 80 kilonewton, so the load coming on one wheel comes out to be 80 divided by 4, that is 20,000. Then you have to give the information about the tire pressure. So mostly it will be taken as 0.56 in case of IRC design. Then you have to get at what points you have to make the measurements. So like we have a pavement, we have this load. So at what point this distance and this distance you have to signify. So this is the depth and this is a radius. So whatever the number of points and depth and radial distances you will provide at that points, the software will estimate the stresses and strain. Like here, the depth of 140 is given. So the thickness of the top layer was 140. So we are trying to estimate the stresses and strain at the bottom of your first layer, just at the bottom of centers of 2 tile. Similarly, you can input whatever the stresses strain you require. You will get the analysis done after running the software. This third point is corresponding to a distance of 640, which will correspond to a point just top of the subgrade. So these 2 points will give you the calculation of stresses and strain for your failure criteria of fatigue and rutting. The main input after this is the wheel set. So here both option is given. You can select a single wheel set, you can select a dual wheel set. So as the standard load is dual wheel, so you can select the option 2 for most of the cases. After doing this, you can run the program and the program will do all the calculation and the information calculated will be displayed in this form. So here you have all the stresses, strain, radial, tangential, etc. estimated, and here whatever the value you have inputted, that will be displayed. I will upload one document that how to use this IIT Pave software. You can go through that document. You will able to understand what these different terms means. Here this Z signifies the vertical distance. Here this R signifies the radial distance. This sigma Z, sigma T and sigma R gives the stresses in vertical, tangential and radial direction. Tau ZR give shear stress. This terms give the displacement. EPZ, EPT and EPR gives strain in vertical, tangential and radial direction. So to analyze, we require the strain in vertical and tangential direction. So in tangential direction, we need the strain at the bottom of bituminous layer, and the compressive strain will be required at the top of your subgrade. So we require the tensile strain at the depth of 140. So here, if you see clearly, in case of 140, there are 2 points estimated, 140.00 and 140.00 L. So at the interface, the calculation has been made uh, at 140 when it is within the top layer, and 140 L when it is within the bottom layer. So I have already explained you that we have to take a point which is inside the top layer. So we will take the first tensile strain as a critical point. And in case of your rutting, you have to estimate the vertical compressive strain at the depth of 640, and in this case you have to take the L value because that points will be considered within the lower layer or within the subgrade. So here in this case, the two critical strains for you is this value and this value. Here we also want to take the strains at the 2.1 at the bottom of center of two wheels and at center of wheel. That's why this two calculation has been done. Most of the time you will find that critical value will be coming at 0 radial distance. So this is how we are going to estimate the strains when the standard wheel or a load is coming on your pavement. So we haven't seen any methodology mathematically how we are going to compute, but we have seen by using an IIT PAVE tool how to estimate this stresses and strain. And let's now see how to use this calculated strains to calculate the allowable number of passes or fatigue life or rutting life of the pavement. Let's see the rutting criteria. So the rutting criteria for 80% and 90% reliability can be estimated by using these two expressions. Here, this EV is the vertical compressive strain calculated or estimated from the IIT PAVE software. The rutting here is defined as the subgrade deformation more than 20 mm. So whatever strain you have estimated, if you input that strain in these equations, you will be able to calculate the number of passes pavement can serve without failing in rutting. Similarly, we may have some design criteria for fatigue as well. Let's see that also. So these are the two equations to estimate the number of passes that can be served without failure in fatigue. In this expression, this ET is the strain or the tensile strain you have estimated by using IIT PAVE software. The constant C and M can be estimated as given here, and all the other values are explained here. Once you input the values of these constant and the value of estimated tensile strain, you will be able to calculate the number of passes pavement can serve without failing in fatigue. So now you have calculated the number of passes pavement can support without failing in rutting and without failing in fatigue. You also know that how many number of passes is going to come on your road based on your traffic calculation. So the number of passes which road is going to have in its design life, that should be less than the number of passes can support in rutting and fatigue. In another words, the number of passes supported in fatigue and rutting should be greater than whatever the traffic is going to come on on your pavement in its design life. That will make your pavement safe, and this will be the overall design methodology for flexible pavement. Here, this 80% reliability and 90% reliability will be selected based on the category of road. If you are constructing an important road, let's suppose a national highway or an expressway, you have to take a high reliability. And in case you are considering a lesser priority road, then you can consider lesser reliability. Let's suppose if you are considering a road for a rural area, you can take a reliability of 80%. Higher the reliability will incur more costly design. Lower reliability will incur comparatively lesser costly design. Or high reliability will result in more thickness of the pavement. Lower reliability will result in the lesser thickness of the pavement. So now the most important thing is how to estimate the design traffic. So in order to estimate the design traffic, first thing what we need is to do a traffic survey in order to know the initial traffic in terms of commercial vehicle per day. Commercial vehicle here means all the vehicle whose weight is greater than 3 ton. Then you need to have the information about the traffic growth rate during the design life. IRC 37s give the information about this growth factors. If nothing is given, you can take the value of this growth factor minimum as 5. On most of the cases, you can adopt a value of 7 or 7.5. Although this value need to be informed to you. Then you need to know the design life of the pavement in years. You also need to know the vehicle damage factor. I've already explained what the vehicle damage factor is. And you need to know the lane distribution factor or distribution of commercial traffic over the carriageway. Let's try to understand what this thing is. So if you have a road which has more than one lane, what will happen that most of the time both lanes will not be occupied. So designing a road which have both the lane occupied all the time will be an uneconomical design. Let's try to understand this with one graph. So here this graph is made based on the data collected in US. So the driving rules and driving steerings having the different position in US and India. You already know this thing. So here this graph explains when you have two-lane road, how much proportions of trucks are aligned in the right lane. So if you have two-lane roads, there will be probability that the fastest moving vehicle will align in the left direction in India and the slow moving vehicle will move from the righter lane. But in US, this will be in another way. So most of the time there will be higher amount of traffic in the left lane in India, but relatively lesser amount of traffic in the right lane. So rather than taking the 100% traffic in one lane or distributing the traffic on both the lane equally, we have to adopt this 80% traffic for the design. Here this graph also explains the same. So if you have two lane and total traffic is 10,000, then nearly 80% of the traffic is aligned in the right side of the road or right lane of the road. You can do the same thing for the 3-lane roads. If this is the traffic for 3-lane, nearly 70% of the traffic is aligned in the, or 65, it comes out to be something 68% of the traffic are moving from the right lane. So it's another way in India. So from the left lane in case of India. So from this graph, we can understand that we have to take a factor which when multiplied with the traffic gives the traffic corresponding to the critical lane. The critical lane is the lane from which the highest traffic will move. For different types of road and different number of lanes in the road, the IRC 37 recommend different values of this lane distribution factor. Like for 2-lane two-way roads, so 50% traffic is taken on the critical lane, 4-lane single carriageway road, a 40% of total number of traffic is taken for the critical lane design. I will just upload a copy of IRC 37 code. You can have a look for section 4.5 in order to get more information on this lane distribution or lateral distribution of traffic. Now we have seen that what is our load distribution factor is. Here the design life of a flexible pavement is normally taken as 15 to 20 years. Now we have the information about all these terms. Let's now see how to calculate the design traffic. The design traffic can be estimated by using this formula, where this A is the initial traffic, D is the lane distribution factor, F is vehicle damage factor, N is design period in years, and R is the annual growth rate for commercial vehicle. Now this initial traffic is taken when the road is constructed, but you will do the traffic survey to estimate the traffic before the construction of road. So suppose you have done the survey 1 year before the construction of road, then you can estimate the initial traffic for design traffic calculation using this equation, where P is the traffic when the last count has happened, and X is the number of years between the last count and the year of completion of your construction, and R is the growth factor you have already seen. So using this expression, you can estimate the design traffic which will be used for road design. That's it for this lecture. In case if you have any doubt, any problem, please try to comment on the video itself. I will try to resolve your all the queries. Thank you.